The traditional disciplines of science, technology, engineering, and math built the modern world. They gave us the tools to compute, automate, and manufacture at a scale previously thought impossible. But today's existential threats, from global pandemics to environmental collapse, have evolved. These are no longer purely technical problems that can be solved in a lab. This is where the silo effect becomes a liability. A mathematically perfect technical solution fails in the real world if it ignores the human factors that determine how that solution is used. For example, a team can develop a high-density battery with record-breaking efficiency, but if materials are sourced unethically or the price is rejected, the innovation never leaves the shelf. Knowing how the physical world works is a start, but it is no longer sufficient. Our solutions are only as effective as our ability to implement them ethically and practically within human society. FusionSteam provides a framework for this new reality. It advocates for a deep synthesis, moving past simply adding subjects together to dissolve the boundaries between them. This framework requires us to account for the molecular, the organic, and the human elements of a challenge at the same time. By doing so, it shifts the focus of education and industry away from isolated discovery and toward holistic, real-world problem-solving. The first critical intersection lies at the boundary between chemistry and biology. The logic here is foundational. At the most basic level, every biological system is a series of chemical reactions. We see this in pharmacology. Stopping a pandemic or treating a neurodegenerative disease requires a precise chemical understanding of how molecular interactions alter our physiology. This is the core of biochemical engineering, designing synthetic materials that can effectively mimic living biological tissues. We cannot solve a biological crisis without mapping and manipulating the chemical architecture that supports it. Now, we shift to the second boundary, the intersection of biology and social science. Biology explains how a physical body functions. Social science explains how that body lives and interacts within a community. Bridging these fields allows for biopsychosocial modeling, which maps biological data onto social structures. In public health, this is how we track pathogens. It's not just about the virus itself. It's about analyzing the urban infrastructure and social networks that allow it to spread. We apply this same logic to neuroeconomics, studying how the biological basis of human decision-making dictates market trends and social cooperation. Modern healthcare and environmental policy rely on this balance. They fail if they don't account for both organic functioning and human behavior. That leads us to the final, often overlooked bridge, the intersection of chemistry and social science. Chemistry dictates the physical materials we use every day, from the plastics in our devices to the fuels and fertilizers that power our economy. Social science examines the human context of those materials, the labor practices, the policy decisions, and the quest for environmental justice. This creates a lens of ethical materialism. In toxicology, for instance, we study how chemical pollutants disproportionately affect specific socioeconomic demographics. Designing green chemistry solutions is only half the task. Those solutions must be socially and economically accessible to developing nations to be considered a success. Climate change is the ultimate test for this model, requiring a total fusion of these three disciplines to address. Chemistry provides the technical foundation by developing carbon capture materials and high-density batteries for renewable energy. Biology is necessary to monitor the loss of biodiversity and to engineer heat-resistant crops that can withstand a warming world. And social science creates the policy frameworks and behavioral shifts required for these solutions to be adopted globally. Without these three disciplines working in unison, global adoption of any climate solution is impossible. FusionSteam provides a path for education and industry to move away from isolated, siloed thinking and towards a more integrated approach. This synthesis helps ensure that scientific progress is supported by empirical data while remaining grounded in human ethics. The future belongs to the synthesizers, the people who understand how to invent new things